Am I audible? Am I audible? तो आइए शुरू करते हैं। आज का जो टॉपिक होगा वो कम्यूटेटर सबग्रुप होगा। कम्यूटेटर क्या होता है, उसके बाद कम्यूटेटर सबग्रुप क्या होता है, उसके बाद कम्यूटेटर सबग्रुप कैसे नॉर्मल सबग्रुप होता है वो प्रूव करूँगा, है ना। तो ये लेक्चर जो है ना वो बेसिक मैथमेटिक्स के स्टूडेंट्स वाले के लिए है। बहुत बेहतरीन लेक्चर होने जा रहा है। मैं आशा करता हूँ आप लोग अच्छे से देखते रहिए। ओके, तो वीडियो को एंड तक बने रहिए और है ना आपको लास्ट में समझ में आ जाएगा। तो ये पहले ये समझते हैं कम्यूटेटर क्या होता है। सो लेट्स से लेट कैपिटल G be a group. Okay, capital G be a group and A and B, these are two elements in the group G. Okay, then A inverse and B inverse. If AB belongs to G, A inverse and B inverse also belongs to G. अब मुझे अभी बताइए A B इंटू A इन्वर्स इंटू नहीं है, कुछ ना कुछ ऑपरेशन होगा इन दोनों के बीच में। A B A इन्वर्स B इन्वर्स, ये दोनों G में है, ये दोनों G में है। तो A B A इन्वर्स B इन्वर्स कहाँ पर होगा? Since G is a group, so this element belongs to G. And this element, such type of element is called commutator. Commutator of the group G. Okay. So यही जो है ना commutator का डेफिनेशन है। क्या विजिबल हो रहा है ब्लैक बोर्ड को ठीक से? हाँ, सब कुछ ठीक चल रहा है, बहुत बढ़िया। तो आइए कम्यूटेटर तो क्या होता है आपको पता चल चुका है अभी। तो आइए अभी डिस्कस करते हैं कम्यूटेटर सबग्रुप क्या होता है। द सेट ऑफ ऑल कम्यूटेटर्स, द सेट ऑफ ऑल कम्यूटेटर्स forms a group which is called commutator subgroup. The commutator subgroup, commutator subgroup, the set of all elements, the set of all commutator of the group G is called commutator subgroup. Okay, and ये जो एलिमेंट है ना A B A इनवर्स B इनवर्स, ये दिस इज commutator in the group G, commutator of A and B. This is commutator of A and B in the group G. पता है मैंने क्या कहा? A B A inverse B inverse is the commutator of A and B in the group C. Okay. Commutator subgroup क्या होगा? So this is denoted by C. This is equal to x1, x2, x3, like that, xn. This is the product of n finite commutator. So C is equal to this such that xi's are, that means x1, x2, xn are commutators, are finite number of commutator, finite number, इसको अच्छे से लिख दीजिए, are such that xi's, बा आप ऐसे भी कह सकते हैं such that x1, x2, xn are commutators. Commutators. So, अभी आप मुझे बताइए the set of all commutators. This, how it is denoted by this? आपको लगा होगा और मुझे भी लगा होगा, so C is equal to A B A inverse B inverse, ऐसा फॉर्म में कुछ होना चाहिए था, है ना? And what is this? This is an element, and any element of the group G is denoted by xi, x1, x2, x3 like that. Okay. So this is the product of commutators. अब अभी ये समझिए, this element can generate all the commutators in the group C. This notation is used in this group. This notation is used in this group, used in this set. ग्रुप नहीं, अभी के लिए मैं इसको ग्रुप नहीं बोलूँगा, इसको मैं सेट बोलूँगा. दिस नोटेशन इज यूज्ड इन दिस सेट टू, आपको ये दिखाने के लिए कि दिस इज क्लोज्ड, है ना. सो दिस इज क्लोज फ्रॉम क्लोजर प्रॉपर्टी. दिस ग्रुप इज डिनोटेड बाय दिस. मैं आपको बताऊंगा. दिस एलिमेंट कैन जनरेट ऑल द कम्यूटेटर्स. So this notation is used to show this set, because this element can generate all the commutators in the group C. How? For x1 is a commutator. For x1 के लिए आप x1 को x1 ही मान लीजिए. बाकी x2, x3, x4, xn इन जितना भी एलिमेंट है यहाँ सबको आइडेंटिटी मान लीजिए. तो प्रोडक्ट x1 इंटू प्रोडक्ट ऑफ सम आइडेंटिटी. सो x1 मिलेगा आपको, लाइक इट x2 मिलेगा, x3 मिलेगा, x4 मिलेगा, xn मिलेगा. ये दिस एलिमेंट विल गिव ऑल द कम्यूटेटर्स. ओके. एंड प्रोडक्ट ऑफ सम कम्यूटेटर्स, पहले x1 को x1 मान लीजिए, x2 को x2 मान लीजिए, बाकी x3 को आइडेंटिटी मान लीजिए, x4 को आइडेंटिटी मान लीजिए, xn को आइडेंटिटी मान लीजिए. तो आपको x1 x2 का प्रोडक्ट मिलेगा, right? So like that it will give all the elements, all the commutators, right? So this can be denoted by this. Okay, ये तो बात हो चुका है. अभी बताइए, क्या ये जो ग्रुप है, ये जो सेट है ना, क्या ये ग्रुप होता है? ग्रुप होने के लिए क्या होना पड़ेगा? This should be subgroup of this. अगर ये जो है ना, ये ग्रुप होने के लिए क्या होना पड़ेगा? First of all, it should be subset of this. subgroup होने के लिए this set C should be subset of G, and operation must be same of G. The operation of C will be same as the operation of G, like that. And you can use one step subgroup test also, two test subgroup test also. So you can use these two type of subgroup test. So first of all, we use one step subgroup test. What the one step subgroup test says? The one step subgroup test state that if S is the subset of G and AB inverse belongs to S, whenever A B belongs to S. पहले A जो है ना G के सबसेट होना पड़ेगा, बाद में क्या होना होगा? For A B belongs to S, A B will also must be belongs to S. This is the one step subgroup test, right? We will use this test. Okay, one step subgroup test. पहले तो दो एलिमेंट यहाँ पे x1 x2 x3 दिस कम्यूटेटर एनी टू एलिमेंट्स एनी टू कम्यूटेटर आपको मान लेना होगा. उसके बाद कम्यूटेटर का ये जो है ना, तो आइए शुरू करते हैं. prove that commutator, this is the set of commutators. The set of commutators is a, prove that the set of commutators is a subgroup of the group. Okay, so prove. So let this will be the proof for the set of commutators forms a group, or the set of all commutators is the subgroup of the group. So this is the question. So let x1, x2, x3, xn, this is an element of this set, and another element y1, y2, y3, like it yn. This is also another element of this, okay, of this set. So these two belongs to C. पहले ये मान लीजिए, उसके बाद आपको क्या दिखाना होगा? You have to show x1, x2, x3, x4, xn into y1, y2, yn inverse belongs to C. वो ये दिखाना होगा. ओके, अभी आप मुझे बताइए, if y1, y2, y3, yn this is a commutator, then what will be the inverse of this element? So पहले तो इसको A मान लीजिए, because this is the product of some elements, so it will be another element. So इसको A मान लीजिए, इसको B मान लीजिए. Okay. Now what is B inverse? इसका inverse क्या होगा? yn inverse, yn minus 1 inverse, y2 inverse, y1 inverse, ये होगा, right? So अभी आपको दिखाना है B inverse belongs to C. क्या आप दिखा सकते हैं B inverse belongs to C? Okay. This is the product of some commutator. Now you have to show if yi B inverse will be belongs to C. If this is an commutator, you have to show this is a commutator. Then you are done. How to show this is a commutator? If yi B, so a commutator if yi be a commutator, you have to show yi inverse will also be a commutator. So this is a commutator, you know yi be a commutator, then yi, this can be written as how? A1, B1, A1 inverse, B1 inverse. This can be written as like this. Okay. This is the commutator of A1, B1 in the group G such that A1, B1 belongs to G. Okay. Okay. What is yi inverse? This is equal to A1 inverse. Okay. B1 inverse. B1 inverse. ओके इसका इन्वर्स क्या होगा? फिर देखिए ए बी, इसका इन्वर्स B1. ओके नहीं, yi inverse will be what? B1 inverse whole inverse. Okay, A1 inverse whole inverse, उसके बाद B1 inverse A1 inverse. Inverse of this element is this, is it? Okay, so this is equal to yi inverse is equal to B1 inverse whole inverse. This is B, this is A, this is B1, this is A1, this is B1 inverse, this is A1 inverse. Have you got it? Have you got it? What is this? This is a yi inverse is a commutator of B1 and A1. This is a commutator of B1 and A1, right? So for if yi be a commutator, yi inverse will also be a commutator. Okay. Then what can you say about B inverse? What can you say about B inverse? B inverse, this is equal to, then B inverse is equal to, this is yn inverse, yn minus 1 inverse, like that, y2 inverse, y1 inverse. This, what is this? If yi be a commutator, yi will also be a commutator. So yn is a commutator here. So yn inverse will also a commutator. Yn minus 1 is commutator here. So yn minus 1 inverse will also be a commutator. Like that, this is also commutator, this is also commutator. So this is a finite product. Finite. This is a product of. This is a product of finite numbers of commutator. This is a product of finite number of commutators, right? So this is a product of finite numbers of commutator. So if these are commutator, this is the product of finite numbers of commutator. So finite numbers of commutator के जो product है वो भी commutator है according to this definition. So B1 inverse, B inverse is also commutator because this is the product of finite numbers of commutator. So B1 inverse, hence B inverse is a commutator. Have you got it? B inverse is a commutator. So, और आपको पता है A is also a commutator because A is the product of x1, x2, x3, xn. This is a commutator. This is the set of commutators. So this is commutator. So this is commutator. This is the product of finite numbers of commutators. So this is A is commutator, right? A is commutator. So A B inverse. AB inverse. What is AB inverse? This is equal to A is this x1, x2, like that, xn. What is B inverse? B inverse is equal to this y1, y2, yn is chi inverse. AB inverse means this AB inverse. And आपको पता है A is a commutator, B inverse is a commutator. So this is the product of this commutator and this commutator. This is commutator, this is commutator. This is the product of two commutators. So this product of these two commutator is also a finite numbers, product of finite numbers of commutator. So this is also be a commutator, product of two commutator. This is also be a commutator. This is belongs to C, belongs to C, right? So this is belongs to C. If A belongs to C and B belongs to C, then AB inverse belongs to C. Hence we have proved. So this is according to finite subgroup test. According to finite. Finite subgroup test, according to one step subgroup test, according to one step subgroup test, according to one step subgroup test, C is a subgroup of C. And this set is called commutator subgroup. So we are done. So this is the proof. Now we are going to show that the commutator subgroup is a normal subgroup. So this is a very important theorem also. So let's get started for the next video.